Good afternoon, everyone. My name is Michael Dickens. I'm a research scientist with Texas A&M High Performance Research Computing. And we've posted a link to the slides if you want to follow along with your own copy in the chat, in the Zoom chat. Okay, this is a summary of what I'll be covering today. We'll log into ACES. I'll introduce you, if you haven't found them already, some utilities that are useful to understanding the cluster. And we'll submit a job script, and then we'll, that job is actually going to take about 3 hours. So we have a job that already completed. We'll review those files. And then when your job is complete, you'll be able to review your files. We'll go over a little bit of AlphaFold history, and we'll look at some limitation of resources for AlphaFold. A couple other things. We'll look at the database files. We have a shared location. And then we'll monitor or we'll look at the output of a job that already completed. And then I'll briefly cover AlphaFold 3 server. So if you have any questions during the talk, feel free to unmute yourself or raise your hand or ask a question in chat. We'd like to hear your experience with AlphaFold 2 or even AlphaFold 3. All right, so first we will be logging into the ACES portal. So go to our website, hprc.tamu.edu. You'll see a portal tab, and then we will select ACES portal access. So portal, ACES portal access. So if you haven't logged into Access already, you'll get a page that looks like this on the left, and you will need to select either your Access CI Exceed identity provider or your institution, and then you can log on, and then you'll enter your Access credentials, and then you'll have to pass the two-factor authentication. I've already done that, so it brings me directly to the portal page. All right, so we're going to access the shell. Currently, the only way to access the shell or the terminal on ACES is through the portal. So we'll go to Clusters, ACES Shell Access. And then we can see it gives us the message of the day. You'll want to read this at least once. And we've got links to our documentation for ACES here. We have our other clusters. You can also see your quotas. Your disk quota, that's how much space your files are occupying, plus the number of files. There's also a file quota. So we do have a limit to the number of files you can have in your Scratch directory or your home directory. If you're working on a big project, we can increase the limit for you. Just send us an email. We can increase this limit for your project. Just be aware that the Scratch directory is not backed up. We do back up the home directory nightly. So this is a place you want to save any maybe JavaScript or something you want to make a copy of in case you accidentally delete them or lose them.
Hi, I have a question.
Sure.
How often is that purged? Is there like, time 14-day kind of deals, like standard Scratch kind of directories or mounts?
No, we don't delete user files. Generally, if the entire cluster disk space is getting close to being full, we will send out a notice to users for the users themselves to remove files, to download the files they need, create a tar file and download their files, and so we can free up space. But generally, we do not delete user files.
Thanks.
I know other clusters will do that if they're idle for a certain amount of time. But we don't do that on ACES. So if you ever run into any issues running an application and you see exceeded disk usage, you can just run the show quota command, and it will show you your quotas for your different directories. Okay, so we have a number of utilities that are helpful to understand what's going on in the cluster. First one covers my job. This is for a job that's already been queued. So you give it the job ID. It will give you some information that comes from both the SEFF command and other information that's in the Slurm database about your job. Max config will show you give you the recommended configuration, SBatch parameters for using all the resources on the compute node. GCA templates, this is a set of template scripts that we have that users are welcome to use and copy and to understand how to create a job script. Job stats, this will create an image for you of the usage, CPU usage and GPU usage if you are running a GPU job, so that you can get an idea of how much memory, cores, and GPU memory and cores your job used. This is especially useful if you have a GPU job and you want to make sure that the GPU is actually being used. If you have the job stats command in your job script, that will show you, it'll create a graph for you to show you the GPU usage. Tool chains, if you're looking for compatible software modules, tool chains can be useful. GPU eval shows you the configuration that we have installed on the cluster, and it shows you the current availability for jobs. We'll go over that one, and CPU eval is also is for non-GPU nodes. We have a couple of others, ENVS eval, that will show you some shared Conda environments, and VE-NV eval shows you some shared Python virtual environments. And we also have a maintenance command. You can check it periodically to see if there's an upcoming maintenance. And I'll review that one also. With all these utilities, you can just type in myjob-h or GPU eval -help, and it will give you some information on usage. All right, my job. We will run this on after our job is submitted, but it will give you the status of your job, the node list that it's assigned if it is running, submit start time and end time, and total runtime. It'll show you the efficiency. It'll also advise you if your job is pending due to a scheduled maintenance. Sometimes the cluster looks like it's hardly being used and your job is still in queue. It could be that there's a maintenance scheduled. Also, it'll check your job script to see if you have any CRLF characters. And you can also ask it to check your disk quotas. So you can check the web page for more information on my job. So when we do launch our job, we'll just type in my job and then the job ID, and you can get an idea of the information that it presents to you. Some of this is really interesting. You can see total wall time, memory utilized out of however many gigabytes you requested. All right, max config. This one will show you the recommended configuration to use all the cores and all the memory on a compute node for a specific partition. This could be different for different partitions. For example, the CPU partition we may have some compute nodes that have 488 gigabytes of memory, but in the GPU partition, we may have compute nodes that have 600 gigabytes of memory. So you can use this to query, depending on the type of job you're submitting, you can see what the maximum available resources are for that queue. The default queue is the CPU queue if you do not specify the partition parameter. Otherwise, if you wanted to see what if you wanted to run a GPU job using one H100, you can run the max config, specify the type of GPU, H100, and the number of GPUs, 1, and it will give you the parameters that you need to use. For example, you'll need to add the partition GPU, and then it sets up the GPU GRES line so that you can use one of the H100s. And it will not give you all the memory and cores for that node, because, for instance, this node may have 2 H100s attached. And if you use all the cores and all the memory and only one H100, the other H100 is unavailable for jobs since there are no cores and memory. So we'll scale it down, either a half or a quarter for the CPUs and memory. And if you can get by with this much, that's great. If you do run out of memory, then you can increase this number. Just be aware that if you land on you request all the CPUs and memory and land on a node that has 4 H100s attached and you only use one, the other 3 are unavailable. All right, GPU eval. We can type this in here. See if I can. Control L to clear GPU eval. So it shows you the configuration, what we have. This can change. ACES is a composable resource. So we may have 4 H100s, or in this case, 8. We have 2 nodes that have 8 H100s attached. We may actually change this configuration, and we may have 7 nodes with 4 H100s attached. So you'll want to check this and see what's available. And it also shows you which for the GPU partition, it will show PVCs are in the GPU partition. So it will show you what GPUs are available and how much memory and CPUs are available. So there, for instance, this node AC011, there are 4 PVCs attached. There are 3 available, so a job is using one of the PVCs, and that job is using up some of the memory and CPUs, but you could still configure a job to use the remaining CPUs and gigabytes of memory. So you could configure a job to use 3 PVCs, 92 CPUs, and 378 gigabytes of memory, and most likely it will land on one of these 3 here. So this becomes very useful when there are a limited number of GPUs available and you submit your job and you're wondering why it's pending. In this case, if you submitted it with 4 H100s and it's still pending, you could probably change it to 2 H100s and see if you can, if your job will be scheduled on this node, or you could also, if you could use an A30, you could switch to an A30 GPU and it may land on this node. All right, CPU eval. This can be useful, especially when the cluster is busy. Okay, CPU eval. Let's see, we've got 52 CPU only nodes. So this has a summary of the nodes and the gigabytes of memory available. You can see cluster is very busy right now, but if you were to run, if you're able to use it, if you're able to configure your job to run 8 gigabytes of memory, you could possibly land on this node right here. But if you were to configure a job to use the maximum CPUs and gigabytes of memory, it wouldn't start right away because there aren't any nodes available with that much memory. All right, maintenance. This is what it looks like. If there is a scheduled maintenance, it'll give you the countdown. And for example, if you ran this command and there were 3 days, 16 hours, 41 minutes, you launched your job, 7-day job, it will not start until after the maintenance. But if you were confident that your job could complete in 3 days, then you could change the time to 3 days and 10 hours or 16 hours. If your job launches within 41 minutes. But just if it doesn't launch and the maintenance time goes down to 3 days, 0 hours, and you have 3 days, 15 hours, your job is still going to wait till after the maintenance. So you may have to submit a couple of times, or also review see what's available, see what nodes are available using the CPU and GPU avail. All right, so let's submit an AlphaFold job. We have a template application that will allow you to copy a template file to your directory. So we'll first create a directory in our Scratch directory. These are the 3 commands we'll use to create the directory and then start the GCA templates utility. So make directory, Scratch is the environment variable for your Scratch directory. And then you can call it what you want, but I just have AF demo in this example. And a good practice is not to use spaces in your file names. You can use underscores. All right, I'm in my AF demo directory. There's nothing there right now. Okay, let's go ahead and launch GCA templates. We have a question about the NVIDIA drivers. I'll show you how to get that information in a minute. Okay, so we have just a few templates on ACES, but we do have a very useful one. This is the one we will be using. So you can type in S and search for AlphaFold. Type in S. So here's the Parafold AlphaFold template script. It runs the latest version of AlphaFold 232. So select number 1. We have 2 options. There's 2 different scripts, or at least 2 scripts. One configured for the monomer PTM and the other configured for multimer. We'll select the monomer PTM. So number 1. And it tells you the name of the script. You can tell by the name of the script what it will be doing. It'll run Parafold for AlphaFold 232. It has the monomer PTM option on an H100 GPU on the ACES cluster. So we will, if you want to copy that, you type in yes, and it will copy it for you. It's just a reminder, this is just a template script. You'll want to read the software manual and update the parameters or command line options for your for the software to match whatever input files that you'll be using. Generally, we select a small subset or a small data set for these template scripts, so they'll complete in a reasonable time, usually within 30 minutes. But this Parafold job, AlphaFold does have an option to run on a reduced databases, but Parafold doesn't have that built into their functionality yet. So Parafold job would actually run on the full databases, so it's going to take about 3 hours. But we have a job that's already complete. We will review. Check and see if there's newer versions of the software. You can go to the software web page, or you can do the module spider command. If there is a newer version of the software and it is open source, we can install it. And then also a reminder to change the SBatch parameters based on your input files.
What's Spider, the Spider module again? What's that doing?
This will search all the software that we have installed as modules.
Okay.
So if we were looking for a software called SamTools, it will show you SamTools, the versions that are installed. Now, in order to understand how to load one of these modules, you'll need to, I just highlighted that with my mouse and then hit Control V and pasted it. You use the module spider with the name of the module, and it will show you the description, but this is what's important here. You will need to load all modules on any one of the lines below. Sometimes you'll see several lines, but you only need to use one line. You don't have to load all 7 lines. So in this case, in order to load this module, you have to load this dependency first. First, module list will show you any modules loaded. We don't have any. So module load that one. And then you can just put this one right after it.
And how was it that you are able to search all available models you knew about, or modules, I mean, you knew it just about SAM tools, but I could search like a list or something like that.
Yeah, okay. Since we've already loaded GCC Core 1220, if we do the module avail, this will show us all the modules that are available that are compatible with this tool chain. The tool chain being GCC Core 1220. So we have more software modules installed, but these are the ones that are compatible with the environment, the module that you just loaded. So you can load any of these modules with what you just loaded. And if you notice, these are core modules. These are modules that are like precompiled binary, so they're compatible with all the tool chains. But these modules are the ones that are available for the GCC Core 1220. If you load GCC 1220, you can access these modules. So we have the GCC Core. Actually, we have the GCC 1220 also loaded. So that's why these are showing up. So if we wanted to load any of these others, you could load this one. Since you've already loaded the prerequisites for the dependency. Okay. You can see this was loaded. Okay, so if we unload all the modules, we don't have any modules loaded, we can do module avail. That's going to show you all the modules we have available. Actually, these are only going to show you the core modules. So we do have on our user guides for ACES, we have a software ACES module list. If you go to our, how I got here was go to user guides, ACES, click software, and you'll see the ACES module list. So then you can search or look through this. Like we don't have the search bar here. You can look through this and see the software, and it's like, for example, Blast Plus. You can click on Blast Plus. Oh, that's just it'll show you the couple of versions of Blast that we have installed. And we will need to update this to include the year, because this has lagged behind, and we want to make sure we're looking at the August 15th, 2024. All right. Another tool chains. For some modules, for example, the GCC Core 1320, if you load 1320, it also loads GCC Core 1320. But if you want to load the Open MPI version, for the GCC version, you'll need to load the main toolchain module. So, but when you do a module spider in the name of the software, it will tell you to load these two, which is fine. You could also just load this one and then load, for example, if you wanted to load Python 3.11.5, let's see what it tells us. So it tells you need to load GCC Core 13.2.0. Okay. It doesn't say you have to load the OpenMPI, but if you did load FOSS 23B, it would also load this one and this one. But it doesn't load Python automatically for you. Okay, let's look at the job script. This runs AlphaFold version 2.3.2. That code is built into the Parafold 2.0 module. And I've set up a job script like this. So the very first job that gets submitted is a CPU job. So notice we don't have we're not specifying any GPUs up here. So the first job is the CPU job. And Parafold, the first part of the AlphaFold workflow is a multiple sequence alignment that is done on CPUs. And generally it's like an 8 CPU max for some of the alignments. So you don't need to use all 48 or all 96 cores for the CPU part. You can reduce that. And if you look inside here, this is the first CPU only step. This runs once this will run, and then once this command is complete, it will come to the next command. This is actually going to submit a job for you. It will submit the GPU job. So once if this fails, then this part doesn't get submitted. So once this completes, your job script will move to the next command, and then it will submit your SBatch job for the GPU part. The GPU part is the that's the structure prediction part. The CPU part is the multiple sequence alignment part. And we have some other applications added here, the job script, job stats command, which will build a graph for you so you can see the resource usage for the CPUs and the GPUs. And we also have this AlphaPickle application that will create quality confidence scores, graphs of confidence scores. So this is how, notice that also the second job, there's a dependency after OK for the Slurm job. The Slurm job ID is the original job that was submitted. So the second job would only run if the first job completes successfully. And actually, if it fails on this step, the rest of it doesn't get submitted anyway. All right. So let's run the CPU eval. We can see there's not a whole lot of nodes with our job script is our job script is configured with 48 cores and 488 gigabytes of memory, but currently we don't have, there aren't any nodes like that. So it could take a while for even the first job to launch, but we know we can get by with 10 cores. And there's even not very many nodes with 10 on there. But it looks like we could get 12, at least 12 jobs. And no, maybe let's see. If we put 10 cores and 10 gigs, we could get five jobs running on this node. But yeah, that's for the CPU part. So we could get 5 jobs running on this node at least. And then someone else could use 8 gigabytes. So I know that this oh, actually, we're going to need about 20 gigabytes of memory. I'm sorry. We're gonna have how much memory this used. We're gonna need about 20 gigabytes of memory. So that's why I recommended scaling to 10 cores and 100 gigs. So you can scale it to 10 cores and 50 gigs, and we can at least get 2 jobs running. Because I've run this before and it takes about 20 gigs of memory. Let's see. So to edit your job, you can do that in the file. If you're familiar with VI, you can edit your job there. If you're not familiar, there's a learning curve for that. You can go to there's an editor built into the portal. So you can go to your directory where your job script is located. Here's my job script. I can click on this 3 dots here and click edit. So we don't need 48. I'm going to use 10, and we know we need at least 20. So I'm going to use 40. And then what you can do at the very beginning of your job script, you can do, oh no, it won't be in your second job, which will be on the GPU node. You can type in, you can add line right here on line after line 54. You can type in NVIDIA -SMI. This will show you the version of CUDA that's installed on the node, on the compute node, and give you some more information about the GPU that was selected for your job. It'll only show you the GPU that you have. Notice we're only selecting one. So in this output, you'll actually just see one GPU. So then save that. And then once it's saved, you can close this. And then I will come back here and you can see there's my change was made 10 and 40. And then my NVIDIA SMI command is right after I load the modules. So then you can submit this job SBatch and then the name of your job script. I'll check the GPU avail again. There's still, it's like a few people may have submitted their job. I will go ahead and submit this. And I'm just hitting tab, autocomplete. All right, so at least we got it submitted. We have a job ID. And you can run sq-me. It will show you your job. My job is pending. And we got an idea that we know why, because there aren't any nodes that have 10 gigs right now, Bill. My job, you can run my job on the job ID. And it will give you some information. It can't give you a lot right now because it's pending. But if it is pending due to maintenance, it will give you a note there. So you can check back on that later. And we have the job already completed that will review some of the output files. But at least I want to make sure you're familiar with how to navigate to your files using the files application. You can launch directly to your Scratch directory, navigate to the AlphaFold demo directory. And then once this job is complete, you'll see the log files and the image files. And for the image files, it'll be a .png file, and you click this and click view, and it will open. Or you can just click this, and it will open in a new tab. All right. So this is just the history. Just put this together so we could see how AlphaFold unfolded over from version 1 to version 3. Starting back in 2018. So in just 6 years, code release actually in 2020. So just like 4 years, went from AlphaFold 1 to AlphaFold 3. So they do have AlphaFold 3 available for academic use. And there are some, the only limitation that they announce is 20 jobs per day for academic researchers. And we'll go over AlphaFold 3 job. The AlphaFold protein structure database, there's a FAQ here that can give you a lot of answers about this. But basically, whenever I started teaching AlphaFold, this number here was at like 600,000. So there were 600,000 proteins in the early parts of this database, but now it's up to 200 million. So I believe all the monomers for the human genome are available here. At least there's a prediction available. Some applications will, if you're running a prediction on a amino acid sequence, they may have a database. If it's already predicted, they will just use that prediction. So it might seem a bit quicker. I think that's what one of the AlphaFold Jupyter notebooks do. So, but these are all predicted with AlphaFold 2. All right. AlphaFold can only utilize 1 GPU. So in your job script, you configure 2. One of that GPUs will be idle. This was taken from their website. I'm not sure if it's changed, but the minimum length is 16 for the amino acid length. Maximum length, there's the maximums. So if you run the AlphaFold workflow, basically, if you were to launch it on a GPU job as one single job, 90% of the processing is done on CPU, and just the last 10% is done on the GPU. So for 90% of the time, say your job takes 20 hours to predict. So 19 hours, the H100 GPU is idle. If you run it this way, and only an hour or two, it actually uses a GPU. So this is why we broke it into, or we're running AlphaFold using the Parafold workflow, which divides the 2 steps into separate jobs. And then I talked about this earlier. Unless you need all the memory and all the cores, which you really don't need it for the multiple alignment step, just use half or a fourth so that the other H100s are available for other users. Okay, here's a shared location where we have downloaded the databases that are required for AlphaFold. You'll see some older databases like 231 or Link 212 or something. Just use the latest, and you can see it's already 3 terabytes and 200,000 files. So it's best to just use this shared location and try, instead of using up your quotas, to try and save the database into your Scratch directory. If there is an updated database and we do not have it, and you recognize that there's a newer version of one of these UNIREF 90s or 30, you can let us know and we'll add that. Or it might be small enough you can add it yourself in your directory, but let us know so that we can share it with everyone. Some of these are only used for monomers and others are used for multimers. But this is actually, Parafold has this configured for you, so you don't have to specify it the way you do with the AlphaFold commands. All right, in order to visualize the predicted structures, we're going to use an application called JMOL, and this is on the portal. So we're going to launch a JMOL job, a portal app job. So let's go back to the portal, interactive apps, and then JMOL. Number of hours, 2. It's enough. 1 core, 5 gigs, that's enough. You can put an email if you want to receive an email when the job launches, but remember, let's see. We did 5 gigs, right? So let's see. Even here. Yeah, we have some nodes with 5 gigs on it, so we have hope that our job will launch. All right. If you ever have any issues with your job and it fails, you can click on the session ID and it will take you to the output, the work directory. Right now, okay, here's the main when you want to look at output log. So click the output log and then you'll find any standard error information or standard out here. If your job fails, it will you can search this log. So that's what this session ID. If your job does fail, this will this window here, or this information about your job, this is the job ID. This will stay open for I think like 7 days. So this will remain there so you can debug it. So we can launch the JML job and you can see here's the application launched for us. So let's go, let's navigate. I'm going to click File, Open, Scratch Training, AlphaFold, and then AlphaFold. Open, file, open, directory. Click this look in, you can go to Scratch. There's training. There's AlphaFold. There's the AlphaFold directory. There is the name of that's the protein. And then the file we want to look at ranked 0. Ranked 0 is the model that had the highest confidence score. So overall confidence score. So we're going to look at rank 0 PDB. So rank 0 PDB. So we did Scratch Training, AlphaFold, AlphaFold, 1L2Y, rank 0 PDB. And you can see that's the predicted structure, which is what we have in this slide. All right, so now you'll be able to view your predicted structures, at least view the structures with this JML application. All right, so in your JML application, you can open the PLDDT PNG. PLDDT, I have a definition of this. I did. These are the basically the confidence metrics, and you can see a higher score up to 100 is in blue, so you can see that the middle of the structure has high confidence. Anything above 90 is very high. So basically, this is a very high confidence of the structure here. Towards the end, confidence is expected to be a little lower, a little bit lower since it's at the end. But you can open this in the same 1L2Y directory. This will be the PLDT PNG. Rank 0 PLDT PNG. Oh, since this is a since this is a PNG file, we can just open it in the files. So we were here. Let's go to files, go to our scratch. Yes, PNG, not PDB. So PNG, AlphaFold demo, out 1L2Y. Oh, I'm gonna go back to, sorry, I gotta go back to the shared. Looks like my job started, but let's go to scratch training. AlphaFold out 2Y. Rank 0 PL DDT PNG. So this is a little different than, actually I think this is this is more zoomed in. It shows you above 89, as opposed to this other one that I have here that starts at 40. So we're looking at the top part here actually. But still all above 90. Is very high confidence. So all of this is above 90. There's a couple right at 89. All right. There's some other graphs if you're interested in the PAE scores, predicted align error scores. This Alpha Pickle software was introduced to us by one of our users, and we added it into our workflow just because it'll create these graphs for you. You can review, for example, the 5 models. That starts, actually model 1 starts with model 1, 2, 3, 4, 5, but the ranked naming starts with a 0. So rank 0 is the top ranking model. So if you were to look in this file, rankingdebug.json, it will give you this information, and then you can see here's the scores: 94.1, 94.8. Here's the order. Rank 0 is on top, so model 2 is rank 0. And then you can look up here and see model 2 had a score of 94.8, which is the highest score of the 5 different models. All right, resource monitoring. So we added the job stats command in the job script, and you'll see a CPU graph for the first job, and then you'll see a CPU and GPU graph for the second job. Now, since we only selected 10 out of 96 available cores, you'll see a little red message here that says you've only selected 10 out of 96. This graph is actually for all 96 cores. So your graph probably look different based on what other jobs are running on that node. But what's most important, or what we really want to see, is to make sure that the GPU is being utilized. And in this case, you can see there were 5 minutes. First part ran for 6 hours. Second part ran, the GPU part ran in just 5 minutes. So the GPU part is very quick. So you can add this to any of your SBatch jobs, any of your jobs you submit. You can have the job stats command. Go to our documentation, job stats. And the way you do that is you just send it to the background with the ampersand like this, run all of your commands, and then the very last line, put it one more time, but don't send it to the background. Put it one more time, and it will create the graph for you. Now let's just say this command completed successfully. Our job stats launched in the background, then this job completed successfully. If this job fails, or this command fails, then this last command will not be running your job script. But you do have a log file for the first command And you can go to the directory and just type in jobstats-j and the job ID, and it will create the graphs that didn't get created since the second command failed. All right, so Parafold, if you haven't heard of Parafold, this is just an application that divides the AlphaFold workflow into two steps, or two separate jobs. We've actually combined submitting the second job into the first job script, so we don't have to have two job scripts. All right, the first part is CPU only. Second job is GPU. So I just ran a comparison of AlphaFold running it through Parafold or the DeepMind AlphaFold workflow. The running times are relatively similar. If I was to run this again for Parafold, it might be 3 hours and 45 minutes, and DeepMind might be 3 hours and 15 minutes. So the time varies, but they're relatively similar. This is overall runtime for the Parafold for both jobs, and the scores are very similar. So using Parafold is a good way to run AlphaFold on a cluster, mainly, especially if you have a limited number of GPUs, especially if you have expensive GPUs. You don't want to have a lot of idle time on your GPUs. So if you want to read about more about Parafold, here's the GitHub page. This is what you'll find in your job script to run AlphaPickle and create the graphs. The graphs are only available for monomer, PTM, or Multimer. And these are the modules you'll need to load for AlphaPickle. You'll actually just need to load these first two. And then this is the command to run. This is the output directory, the AlphaFold output directory. And here's the definition of PLDDT. Per residue estimate of prediction confidence. All right, I'm going to go back and check my job. Okay, so my job is running. This is the AlphaFold job, the Parafold job. And I've also got, there's my JMall job, which is still running. So when you're done with it, with a portal app, you'll want to delete that. You can go to your jobs. You can do it here, interactive session. And then I'm done. Since I'm done with this, I don't need it to run another hour and 45 minutes. If I'm not going to use it anymore, I can just click delete. And it frees up the resources for other users. Then if I go back to the command line, hit up arrow, now I can see it's just my Parafold job running. You can actually type in, see how many people are running Parafold. 1, 2, 3, 4, 5, 6, 7. We've got 10 people running Parafold, which is good. One person has theirs pending. Because there's not any nodes that have 48 cores available. All right. So here's an example of what I was talking about having the GPU idle if you run it with the DeepMind workflow. Here's DeepMind workflow, which is one job on a GPU node versus Parafold, which is two separate jobs, one on CPU only and one GPU only. And I just want to compare the GPU usage for these two jobs. So you can see this is the number of hours of this entire job. So the first 2.5 hours of the regular DeepMind workflow, the GPU is idle. This is the GPU usage. It shows you the type of GPU, H100, gives the job ID and the runtime. for GPU index 0, it was idle for 2.5 hours. So that means no one could schedule a job on that using that GPU for that long. And this is probably a shorter prediction. Some predictions can take 20 hours. You can imagine it's not good practice to have a GPU idle for 20 hours. So with the Parafold workflow, this is the GPU job. You can see it only took 10 minutes to get the GPU job complete. So the first job was the CPU only job. That was the 3 hours. So we didn't hold the H100 idle for 3 hours since we scheduled it on the CPU only. So you can see how useful the Parafold workflow is. And it does use the AlphaFold code in the background. All right. Any questions so far? This job is going to take about 3 hours. Yeah, version 3 is it's closed source, it's not open source, but they do have a academic license for academic researchers. You can use this AlphaFold 3 server. We don't have the AlphaFold 3 code available to install on our clusters. So the only way to run AlphaFold 3 right now is to academically is to run it on their server. This is just, I pulled this from their abstract. You can read the paper about this. All right, I just pulled this, copy this server terms. There are a couple of, even though you can use it for non-commercial use. There are a couple of restrictions here. You must not use the AlphaFold server or its outputs in an automated system that predicts binding or interaction, such as Glide or Autodoc. I haven't used those. I'm not familiar with that, but just make sure you read the terms of service before you use their application in your research and publish on it. But I'll go ahead and show you. This is the interface. You can go to alphafoldserver.com. And then continue with Google. I'm logged in. Am I? Yes. Okay. Okay. Looks like I have this pasted from last time. You can copy and paste this, or just type it in. This is the one L2Y sequence that's running on our job right now on ACES. So you could probably do your own comparison with this. Run this in AlphaFold 3. Actually, I've already run it here. I'm going to see what kind of prediction scores or what output it gave me. So you can go ahead and run this. It says how many jobs you have remaining, and I think if you save job, you need to preview job and confirm and submit job. Okay, so you can submit the job. I'm actually from the job I submitted earlier. I didn't see any results. I didn't see any overall scores. So I guess if this was orange, you could say it was very low, but overall, their prediction, their scores are above 90. I don't even see any in towards the end maybe in the 80s. You can look around on this site. I don't know, maybe in the FAQs to see if you can get a specific score, so you could compare it to what you get on ACES. All right, these are the references. If you use AlphaFold in any of your publications, be sure and reference these papers or the Parafold paper, or if you use AlphaPickle, also there's a reference for AlphaPickle. All right, here's a link to our documentation, our user guide, which we looked through a little bit of that. And if you have any questions, you can email us and let us know when your issue's resolved, because we use a ticketing system. And that's pretty much it. So we have a survey. If you want to take the survey, there's a link here. We'd appreciate your response. And one of the main, if you're sending a help desk ticket, a couple of the main parts of main information the main information we know we need to have is the job ID and your which cluster you're using. From there, we can get most of the information that we need.